For question 9, which is similar to a problem we had before, the graph shows the variation with time t of the displacement x of a particle undergoing simple harmonic motion. Now, this actually would be this one over here. Your starting position for the graph is actually at its maximum displacement at the amplitude. So we're going to get x is equal to x0 cos omega t. Now, because because a is equal to minus omega squared x, so we get the negative proportion graph between the two. This would be also a cosine graph, but it would be the negative cosine graph, so it would be b. It would be this one over here. So you see, when x is positive, the acceleration is negative, and it's going in the other direction to the x. It's decreasing from that to 0 at the same point. So you get the proportion part. For instance, when x is 0, a is equal to 0. When x is a maximum, a will also be a maximum, but in the negative direction, in the opposite direction. Nice. Going on to 10. It says a wooden block is at rest on a horizontal frictionless surface. A horizontal spring is attached between the block and a rigid support. The block is displaced to the right by amount x and then released. The period of oscillation is t and the total energy is E. For an initial displacement of x over 2, which of the following shows the best estimate for the period of oscillation and the total energy? Now, firstly, it's important to realize that with simple harmonic motion, the period remains roughly the same. So, for instance, if I have a pendulum here, and say this is equilibrium position, and I have it at that point, and it swings to and fro like that, the period would be of a similar amount. I mean, we assume that over there, where it would swing there and there, the period remains roughly the same. So we would have either this or this. Now, looking at the energy part of it, we need to look at our total energy, which is this formula over here. Let's make this a little bit bigger so that we can see it. So I have that. I have my ET is equal to a half m omega squared x0 squared. So it's dependent on an x0 squared. So when I halve it, the square of that is going to be x squared over 4. So there's going to be a quarter, really. So we are going to be looking at B would be the correct answer. So always important, look at this, think of the formula. What formula is related, and work from the formula. For question 11, which of the following correctly describes the change, if any, in the speed, wavelength, and frequency of a light wave as it passes from air into glass? Okay, now we know when it goes from air into glass, the speed definitely decreases, and the frequency always remains the same. This is an important point, and because we have that your speed v is equal to frequency times wavelength, if the velocity decreases, the wavelength must also decrease. So it's actually going to be a. It's one there. And for question 12, we have the diagram below shows a pulse traveling along a rope from X to Y. The end Y of the rope is tied to a fixed support. When the pulse reaches NY, it will, because it's a fixed support there, it is going to be reflected and inverted. Basically what happens here is we have an application of Newton's third law, that the rope is going to apply a force on the wall in that direction as it hits it, as this pulse hits it. So as it comes in here like that, it will apply a force, and the wall will apply an equal and opposite force downwards, which will cause the rope to invert and to go back in that direction, like that. So that would be C.